Okay. Hello, everyone, and thank you for attending today's webinar focus on fighting AML and trade fraud with graph and machine learning. Exciting to share today. And as I just mentioned, everything today will be recorded and sent out after the webinar. If you have any questions, go ahead and leave those in the box and we'll get to those at the end. With that, why don't we go ahead and go to our first slide, which will talk about what we're going to do today. So I'll be the first one up in our conversation. Chris LaCava will walk us through sort of the art of the possible and using some case studies in sort of how we can do that. And finally, Graham Gansel will follow up with how did we do all of this great stuff? How does the technology behind the scenes help us really sort of get to the heart of what's going on? So with that, let's get on to the first slide. Well, first of all, AML is huge, right? No one disagrees with its breadth and sort of depth of how much it's costing us. The idea that money laundering now has moved from simply, what used to be bribery and corruption and simple Moldovan sort of transfers and those kinds of things to far more sophisticated and more interlinked kinds of money movement and transactional hiding, et cetera. As we get stronger, they get stronger, but the numbers are staggering. And so based on these kinds of things, that takes us to our next slide, where we start to lean in now on where is it coming from? This idea that 2 to 5% of a GDP is still staggering. The other takeaway here is that AML and what FinCEN and other agencies are telling us is that it's no longer in simple sort of transactional areas, right? It's also in retail, it's in casinos, it's in real estate, it's in healthcare, right? We all have now this fiduciary compliance capability where we have to fill out our SAR reports, and the fines are hefty, as we'll see here in a minute. The other item is it's not just scoring, right? When we get into these now, let's look at these, right? The idea that billion-dollar fines are being handed out. Now, these are not new, and for those who've been around, you've seen these before, right? And that is that simplicity in this is that the way transactions were either found or could have been found, whether it was by a human or a system, were out there. Now, these were from a while ago, right? So the Bernie Madoff one, right, was multiple sort of transactions in with no real investments happening or paused or simulated investments, et cetera. And then the other one is just simply there's too much. There's so much now that we're seeing transactions, the additional layers are going on. And then the HSBC fine was the accurate categorization, the ability to recategorize incorrectly certain activities. And what we're going to see today then are the ways to do this, and the ways to do this at speed to go do that. And so again, these are huge numbers, right? And so on our next slide, what we want to talk about now is what are we going to show today? Now, one of the things that we do here at Expiro is we spend a lot of time in different kinds of fraud. And one of the things that happens in this then is we have anti-money laundering. But what happens now is we start to see these adjunct departments inside of our bank or wherever we're at, whether we're a broker dealer or where those things are, they all start to look at multi-connections. So perhaps they're doing it in an IoT or a cyber, they're creating a false ID and a bank account, and then they're leading up to the AML, right? So what we start to see now is this inner web of business use cases. In the second column there, we now need a layperson, right? A level 1 analyst, somebody who's looking at trades or broker dealer arrangements, all those kinds of things, and or folks that perhaps don't care so much about this really cool stuff that Graham's going to tell us later about, which is the over on the right, the patterns, the detection, the predictive, the analytics, and the scoring. All of those are incredibly important. And although seemingly hard, what we're going to show again today is the way to bring those together in such a way that a layperson and the system can really help the human reduce those false positives and increase the accuracy. So on our next slide, what we want to do then is let's talk about those, right? Anybody in investigation or anybody in compliance or other kinds of groups or heads of business, right, want to do these kinds of things. I want to increase my accuracy, right? I want to make sure that when a human learns something, it teaches the system and the system gets better. The other thing then is really sort of bolting on to what you already have. Most every customer we've ever worked with already has many technologies. They may have Actimize or CyberSource or whatever those are. What we're going to show today is a fast way to do that, in addition to bolting on top of it to make these accuracy increases and start to do that. The other big thing is those false positives. Just because I have 100 investigators or 5 investigators doesn't mean I don't have 10,000 in my inbox of things that I need to go do, right? We need to high grade those. We need to accurately start to say, human, spend your time on these, but not on these. The other thing then is, given that 8,000 or 9,000 a day or more, hundreds of thousands a day in some of our customers' cases, how do I increase that speed? How do I get it down to a manageable number so I can clear it for the day? Because ultimately, if I can clear more trades quickly, I can have my customers be happier, they can make more money, and I can make more money, and I don't need to go to jail to do it, right? The other thing then is sort of picking those risky things, right? Letting executives, senior management, or key people in the group be able to do that. And then finally, the system that gets better over time. That is not a dream anymore. And as we'll see today, there are some things that we can do. So on our next slide, what we see now is, how do these things all fit together, right? So we see AML, we see cyber, we see investigations, we see fraud rings, we see all these things all tied together. And whether you're on the business side and you want to make more money, decrease your cost, or quite frankly, mitigate your risk, they all play together. So over on the right, you see a hard line and dotted line. So although unassuming, customer information, or know your customer, or know your customer's customer, in the case of a broker dealer, with a true end customer, or banks or accounts, or what those things look like, right? Those all cascade down this same list. So although that's sort of our source data, AML and what we're going to talk about today for trades is all tied to that. And so as those different use cases work, over on the right, we now see us as the human group that actually has to go investigate that, and where those tendrils are, where that data, more importantly, is connected, is incredibly important. Now on our next slide, what we're going to see then, and Graham and Chris are really going to bring this home, is that many people today are throwing machine learning at it. And that's great. That's now becoming the new baseline, and it is increasing. It's making lives better. But a Python notebook or a Jupyter line of code doesn't help us that much. It's good, but mere mortals can't wield that kind of a weapon, right? It's hard. What we see then is, if we combine that with now an easier set of algorithms, things that, again, you can sort of plug in together, where we can start to see those insights, we see a huge lift of roughly 6%. Then on top of that, what Chris is going to show us is, if we put those in the hands of laypersons, but do it in such a way where you can see it and it makes sense, and then they can interact, we see an overall boost of 11%. Now, those are big numbers. And on our next slide here, we have a couple of examples. Now, these are from real customers, right? And this is from real work. And these are the interface styles that Chris is going to walk us through. But the ability now to go in and say, I can increase my accuracy with our customer on the left, that's a huge number, right? And then the other accuracy that's here is that to decrease the workload by 40%. Is in that same customer, right? And that's an enormous gain, right? In addition to the ability to obviously avoid fines and be more compliant on our SARs. The other one then is that investigation of 12%. We've got another customer that basically looked at that 12% on the connected data investigation, right? To increase the accuracy of their SARs was enormous, right? They had a previous fine, and now that has basically become something in their rearview mirror, because the tool allows them and their teams to do that, right? So these are great numbers. On our next slide, we're going to now set up for what Graham and Chris are going to talk about today, right? So there are some subtleties. So just trading stocks, trading bonds, equities, commodities, those are all great things. But these are a few of the ones that FinCEN has called out, and the ways that these are used, we'll sort of double click on today. The idea of future commissions, right? So I prepay, my customer prepays a broker dealer for future work that's going to happen. Well, that can get you into hot water, and you need to sort of paper trail that properly. And we'll see how we do that. Prime brokerage agreements, right? So what happens now is, I have a prime broker and a client sort of sharing an account. I can do a give up trade, or basically what looks like on paper a real trade, but in effect, I'm just sending money, turning around, looking like I'm doing a broker and a trade, and then it turns out to be nothing. So all I've done is just move money, which of course is something that needs to be transacted and watched. The idea then that a bank or someone who's in more of a trading facility can actually offer insurance. Well, now I'm underwriting insurance as an odd product, if you will, inside of a brokerage account, and then I can account and do those linkages, and then I basically prepay large amounts for that insurance, and of course then I cancel it, right? So now I've just laundered that money. Shell companies, we see this all the time, right? Where companies don't really have an adequate ownership. Graham's going to talk a little bit about ways to look at other data and other kinds of things that we can sort of proof those between a black and a white list, right? But the idea now of taking that shell company, sniffing it out and realizing before accounts and transfers and trades have actually happened. Cryptocurrency, that's obviously a new one, right? So the ability to offer asset trading of cryptos and then being able to see ones that may even be stolen or other kinds of ones becomes now sort of a new twist on sort of how we're trading and what we're doing. And then mutual funds, right? Many kinds of mutual funds with interest or low interest or high interest, right? Whatever that is, right? Where they park the money and then pull it out. Now, these are just a few of the ones that FinCEN has talked about. And what we want to show now today in context is how do I do what I normally do in trading? How does the system find these things for me, right? And then bring them to the human. Okay. On our next slide, now let's talk a little bit about that. So we have kind of the table set, right? What we now want to do is we want to find it. We want the system to help us find it. We want to visualize it. What you see on the right is a way of showing those connectivities from the data, and Chris is going to walk us through that. But this content of a case, how do I take an alert? How do I set it up as a case? How do I add that for investigation? And then if I do find something, let's really dig in. Let's make sure it's a proper SAR. Let's get it over to the authorities. But now I want to teach the system what happened and then prevent it going forward. And then more importantly, the accuracy goes up as I do that, right? And so this loop, if you will, now can be automated and systematized, if you will, in a simplistic way, which is extremely important. On our next slide, we start to look at how this works, right? So AML and trades and trade sanctions and how that works together. Those are only one or two groups of an entire potential set of groups. Now, how do I take those pods? So maybe I'm looking at a series of traders or broker dealer events, right? What happens when suddenly I realize that that was actually connected to cyber? I need to have the ability now to open up the data so that my investigation can connect to other people's where now I have these teams and security to go do that, and so on and so forth, right? In some cases, some of these are very sophisticated ones, but those silos are what's killing people today. And that's a very important fact, right? What happens then is once some of the ones that we've seen in the past, right, where the cash one was, they knew that the groups were not talking, and they were able to turn it from a cyber to a hack to a credit card to basically some trades and then go push that money all the way out to an ATM. That's a classic case of how they skip through these business units to sort of find the weak spot, right? It wasn't just a singular weak spot, it was multiple. And so the systems we'll see today will really lean in on how we do that and then have the system learn in general. And then on a need to know basis, each of these teams can see their information. Okay, so on the next slide, what we see now, and we'll see this again, the point of this today, where we're going is, as I'm the trader on the left and I make my trade, right? There is a trade book or book of data, there's trade information and blotter. That is combined with information for other account data, for other kinds of information, right? That's that interlinking of those other kinds of data, whether it was a wire transfer in to get the money to trade, or it was just simply a deposit, right? How did that money get out? How did the money get in? And then we see our white and our black list, and Graham's going to talk a little bit more about this. But the point of this now is we're going to show you both sides of this. We're going to show how a trader does what they do, how perhaps they're doing some things on the other side, how we can alert them in a simplistic way, not to alarm them. But then those of us who are in the investigation world, we can dig in, right? We can see what happened, and we can find things we didn't see from the human eye or a spreadsheet. And there's a lot of folks that do that today as well. So on the next slide, let's talk a little bit about what this looks like. Now, Chris is going to show us what this is. Standard trading desk. normal rules of trades apply. You may not have one. Obviously, we make those and do those for a living. But the concept here is simple. I may trade. I may watch some of the alerts on my phone. I may have a more advanced version. I may be a broker dealer. I have a bigger version, right? So the point here is I can manage and do all of these complex things, right? So in this kind of interface, pretty straightforward. Now let's switch over to the next slide, where we start to dig in. What I want to do here now is, where did that trade go? Where are those things? How did the human sort of get involved in this? How did the broker dealer do what they were going to do? Did they trade money, move money? Where is that going? This is where Chris is going to really lean in on for us. And what we're going to see now is this may be one user on the investigation. There may be multiple. On our next slide, what we start to see then is this combination of creating a queue, right? The idea that maybe a level 1 investigator says, I want to see what are the things that I should potentially draw my attention to, right? I see warnings, I see KPIs, I see the ability to sort of just say, human, you should do this thing. And then I see a little pop out window here where maybe I then give them one snippet lower of why they should reject it in more detail. Maybe there's some geography involved. Maybe there's a machine learning moment that Graham's going to tell us about here. And then as I do that, it will sort of send it back in. On our next screen, we can see now that what I want to do is, maybe I have a forensic one, right? Which is what happened in time. Where did it go from? Where did it go to? I can see things that where perhaps they're popping up here, right? These are called swim lanes or subway maps, right? Where I can see contextually the idea of time and how that affects what I do and when it happens, so that I, as the investigator, can say, well, maybe it wasn't what I originally thought, it was something else. On our next slide, we can talk about that geospatial. Now I can see, well, the money was transferring from a region to another region. I can color code those so the humans sort of make sense of those, right? And I'm able to sort of move into those aspects as I see those. On the next slide, right? Now I can see that further one, I can go find similar. This is a huge potential, right? So if I find something I don't like or something that's bad, I can now potentially say, well, maybe I found it in one place, and then I want to apply it to brokers or broker dealers or end customers. I want to widen the net to say, what did I miss? Maybe what did the group miss, right? Now I can go find those in a very simple and easy way that the human understands in how to go do that. Now the system will do the work for them and then come back. And so this is, again, a moment that Chris will be speaking about. On our next slide, now let's just get right to it, right? So I'll hand the mic off to Chris LaCava. And Chris, we're excited to see sort of how these things all fit together.
Great, thanks, Scott. So one thing to note that's important is that we're going to see a few concepts, solutions that we've put together. But when we're talking about fraud investigation and trading and all of the constituents that are involved in those workflows, we're talking about a pretty long chain of a lot of information passing from one party to another. And there are tools specific to each of those parties and stakeholders as things go through the process. So today we'll be mainly focusing on the investigation part and a little bit on the front end side of what this may look like from a trader perspective. But it's important to note that there is low level analytics going on by data scientists and other analysts, all the way up through investigators, as well as line of business folks and even executive stakeholders. So those views into the data that we're going to be looking at today, it varies. It's a heterogeneous list, and there are sets of approval chains and a lot of things that go into considering building solutions for each of these constituents. And at Xpero, we pull together solutions that are custom tailored to these different constituent classes. And we'll get into some of the details on that as we look at some of the concept screens. Along those lines, it's very important to note that even though these things are tailored to a specific stakeholder, we need to make sure that there's interoperability between these systems, both back end and front end. So they may see it through a certain lens that pertains to their workflow or their context, but we're looking at the same type of data, and things that update on one side are going to reflect on the other side. And we'll get into this a little bit more as we look at this trader versus investigator persona that we're gonna walk through an example in a second here. So we're gonna basically jump in to an example of what this may look like from a trader perspective, and then I'll walk through a simplified investigation on how possible anomalies from trades manifest themselves and how investors dig into that and actually find, potential bad actors. So I'll kick over to our example here. And this is what, a typical trading portfolio based app would look like. This actually is based on a toolkit that we produce and is offered in conjunction with our partner OpenFin. It actually just launched this past week. So if you're interested in that, go check out our website and OpenFin to see more details about this solution. But basically, we're looking at a set of positions here. If I were to make a trade, it may flag that trade for some kind of issue, in this case, a compliance issue, possible compliance issue, but it's testing against a set of flags. And if one of those flags is tripped, we basically would show that to the trader proactively. And so basically that is, there's a whole series of things to mitigate this on the trader side, but really what we want to focus on what this looks like on the other side. So from an investigator perspective, we may be monitoring things at an aggregate level from a dashboard similar to this, where we've got a set of KPIs that are telling us some high level information about people of interest, flagged incidents, things that trip certain alerts that we've put into place. We can see some of that stuff basically broken out and categorized from geography to trends. We've also got a set of recommendations and things that hit thresholds, or there's abnormalities in certain locations or in certain certain other categories that we're looking at. And then we've got these lists. So Scott mentioned that there's a lot of alert fatigue around just the mass amounts of information and the alerts that information may trigger. I think ground zero for making this a usable application would be to just be able to bring to relief the things that are important and let the false positives move down the list and don't attribute to that false to basically that alert fatigue. So in this case, I've got a few alerts in that are new. And those are things such as possible violations of a trade with a constituent in a company that's on a sanctioned list. There are other thresholds such as like frequency thresholds and even some of the things that Scott mentioned around large amounts of money moving in future payments for via commission, and then just flags around things such as like insufficient funds and multiple attempts to try to draw money that's not there. So these are behavioral things that may kick off an alert that we've configured in the back end. And then this also keeps track of things that we're watching. So if we've got things that are open and we're watching them or we're moving them through an escalation process in our investigation organization, we can track those as well, and we can even see how these interplay with some of the new alerts that come in. So I'm going to go ahead and click on this one here and just drill into it in a little bit more detail. And I notice that that there is in fact a country that's on a sanctioned list that is linked to some transactions. So I can see the party directly associated with that, and some of the transactions that are around an account that is also linked to an investment, and then what the other side of that investment trade looks like. So this is this is troubling because this trips one of the sanctioned list countries. And I'm going to drill into it a little bit more detail, and I can see, any of these entities basically, but in this case, the party that's directly relocated to that problem location and the account that we're looking at. I can see some high-level information around what their aggregated risk score is, and that's probably directly attributed to that sanctioned country in this case. And then I can see how that distributes out to all the other things that it's connected to. I can take certain actions to basically progressively disclose more information about this network. So we're looking at the first degree of connections here, but I can extend that ring out to see if I see potential nefarious activity, I can see how that distributes out of this network. And you'll see here that there are things that are directly related to things that are obviously on the sanction list, but then you can also see how that risk distributes out just by association. So it dissipates as those rings, as those concentric rings of connections to the primary issue are move farther and farther away. But you can see that there's a blast radius here, basically, with something that's obviously problematic, but then it has residual effects as it ripples out through this network. So in this case, I want to drill in and I want to potentially create an investigation or add this to an existing investigation. But I also am troubled about this trade, so I'm going to actually create a alert trigger that will actually look for some behavior that's specific to this. So now I'm going to walk through a workflow of how I actually configure an alert trigger to basically zoom in on something that's potentially problematic and find other like things that come in, or maybe even just extend that particular incident. And the first thing I'm going to do is add some alert trigger criteria. So I'm going to add some geography aspects to it. And in this case, I'm going to look at that specific country that we were looking at that was on the sanction list. And then I can add other things here. So this is going to establish, hey, I'm interested in this geographical area. I've seen this come through a couple times. This seems to be a potential hotspot where I've got some exposure to transactions that are hitting things on a sanction list directly or indirectly. But I can drill in and maybe add other areas if I want to not only look at one country, but I want to look at other parts. I can expand that simply by just extending it on this map. But then I'm also going to add other criteria to this alert. And one thing I can do, because of that network data modeled in the way that it is, and Graham will get a little bit more into this, I can actually run algorithms on it. So not only do I want to look at that geographical area and anything that's directly related to that country on that sanction list, but I want to cluster things that are associated with it by certain criteria. And so I'm going to see where, within 5 degrees, where all the connections are to any of the activity that happens to be linked to that location. And then I can add a couple other things. So I can start to add some logic in here and say, not only do I want to detect that, but I also want to see anything in that area that has a high level of frequency of transaction. And basically what it will look at is a pattern in the data. So a time constrained pattern that says within this time frame, I want to see if there are transactions that are firing in a certain amount of time in rapid succession. And so once I've got basically my rule set to trigger an alert, then I can walk through and I can attenuate some of the weights on some of the things that I talked about, the underlying algorithms basically that build that composite alert trigger. I can start to fine tune it. Once I've got that to a point where I'm happy with it, I can start to add actions on what I want to do with the results. So the first thing I would do is set when I'm going to run this. Is it going to be an immediate thing? Am I going to want this to trigger on an action? Or in this case, I'm going to run it as a batch every night. And then I can add additional actions. Once I hit results, how do I want them reported? Well, I want them to go onto my dashboard and my transaction queue that we were looking at earlier. And I also want it delegated to these 2 teams, 2 level 2 investigation teams. And so basically gives them a window into what those results are. That escalates it, if you will. Once I've gone through all the criteria and I think I have something, I have a sample data set, and I want to just make sure I can run the logic that I've set up for this set of alert triggers and test it out. Make sure that the triggers validate, make sure that the weights are in the right place, and make sure that the actions are actually valid. And it runs it on a known set of test data. And I can go in and see, in detail how it interacted with each of those test records. But I'm going to go ahead and save this, and then come back after a period of time. And what we'll see here is that alert that I created sometime in the past actually triggered, and I'm looking at a specific set of time down here. So I've got risk ebb and flow in this period of time, but this trigger and all these KPIs actually are bound to this histogram here and time filter that I'm looking at, and I can move this through time to see how things change. But I'm going to go ahead and click in here and see what my alert trigger actually found. And you'll see some familiar names. So we've got that same party that we were looking at before here, as well as the broker dealer that it was connected to. But there's a different risk profile. You can see, first of all, a lot more information because we cast that net a little wider. But also that risk and that weighting that we did has actually transferred a bit more through this network now. This network's a little bit richer, but also that risk is down at the investment party level in the broker dealer. So a few things to note here. This individual that we were looking at, now we can see additional connections. Not only are they connected directly to that account that we were looking at, but also there are other parties involved, and which are companies that all roll up to that individual that rolls up to that sanctioned list country. There are also accounts with a bunch of transactions here, different types of trading transactions, all within a very short amount of time. And if you look at the amounts, there's interesting things to note about the amounts as well. It's a very specific dollar amount. Maybe they're trying to get this under a wire that would otherwise trip a signal. And then you see this prepaid commission. So between the transactions between these parties are a little suspect, but then you also see that you've got a pretty high payout here for future commission. So that's interesting. But then you also see this account directly related with the deposit. So that's actually pretty interesting. And if we see where it actually tripped from based on that set of alerts that we set up, we can highlight the specific categories that it tripped and see what we're looking at here. So for high frequency, these things all fired off within a very short amount of time. And then this thing came through this back door here. So this is an indication of potential nefarious activity, even beyond the intentional or unintentional effect of having some degree of connection to a sanctioned location. So this is one of many use cases that we explore in AML, and specifically related to trading. We can see how taken one by one as a line item in a grid, this may not actually be that big of a deal. And in fact, in earlier screens, we showed that there wasn't a lot of risk attributed to these parties. But when we look at this in total and we see the big picture, we can start to even see things that that normal algorithms wouldn't be able to pick out. So that's basically one of many benefits of having a unified data set, being able to show it in a networked situation where you can see the whole topology of activity, and then using the powerful algorithms that I think Graham will mention a little bit more around being able to detect distributed risk, but also look at communities that may have non-obvious behaviors, and then matching those behaviors to similar behaviors of a known pattern of activity. So I'll kick it over to you, Graham, and you can drill into that set of topics.
Chris, and thanks, Scott, for teeing it up so nicely earlier as well. I'm going to jump into a couple of specifics about how this technology works behind the scenes. But before I do that, let me just mention what we think is happening here in 2021, and talk about sort of the differences in the financial services domain as they relate to these fraudulent behaviors. So before we go on, just have a slide here to mention we have a lot of material on the implementation and specifics of how these systems work on our website. So if you're interested in the technical details, you just jump over to our blog post page. So on the next slide, I want to talk a little bit about something that we find endemic to the financial services industry, and especially inside of the analytics domain in the fraud analytics setting. We commonly see this separation between one-off implementations on the left side, we're saying data science projects, and fully productized, integrated with UI that traders can see and that compliance officers can see in the data products category. The beauty in the financial services domain, and especially in the financial crimes domain, is that we are often early adopters of advanced technologies and advanced analytics, as everybody I'm sure is aware of. The disconnect, though, is that we're not always able to action on the analysis that our quants come up with. So our quants are building these analyses on the left-hand side, and it is difficult to get them into product on the right-hand side. So as we've seen in Chris's screens, and as we see on the next slide, we require that the outputs of those analytics are highly visible and connected in real time to the apps that the folks who are taking action on these insights can see and can see rapidly and with effective, as Chris mentioned earlier, blast radius, with effective outreach into the effects they'll have on the business as a whole. So how do we operationalize these activities? How do we make these systems work? Well, it all starts with data. And the data that we include is from a variety of sources, right? We want to make sure that we are integrating the most powerful pieces of information that are available in the market to be able to more accurately characterize the behavior of the transactors that are doing business with your company. We see a few here, of course, open corporates. We have information from the various governments. On this slide, we're just showing the United States government, where we actually have insight because of previous behaviors into some of the good and bad known actors who are doing business across the globe. That information can be integrated with the middle set of data providers there, like the cyber sources of the world, Actimizes of the world, where we try to map together not just multiple data sources, but also multiple decision sources. So if there are pieces of information you already have feeding into your organization's data structures, like for instance, fraud-based analysis from a company like Actimize, we can integrate those data sources with the behavioral systems at your company and alongside the data sources you see here. And how do we do it? Well, on the next slide, we're showing a common framework, financial industry business ontology, FIBO, that allows different data sources and different organizations to have data sources which are compatible. These data sources talk by having a common knowledge-based data structure, sometimes we call a knowledge graph, which is what you're looking at here. It is highly complex and nested. All of the various bits and bobs and details aren't important here, but it is important to recognize that once you get your data into this structure, which is the structure that we use in that screen that the screens Chris showed, that it allows you to communicate with the majority of financial institutions in the world so that you can gain knowledge that they already have in their systems. Like for instance, in the FinCEN list, you want to make sure that you know, hey, these are known bad actors. We don't want to transact business with them, right? So that's just one example. Okay, so let's jump back into something Scott showed a little bit earlier here, which is the actual behind the scenes logical architecture of how we can perform this anti-money laundering fraud detection. So all of the data sources we just looked at are on the top of this slide, being ingested into a common data store. And actually, importantly, that common data store is composed of links to physical, tangible data structure in your organization, or can be linked externally to some of the data sources we just talked about. Those pieces of information are then used in using that FIBO data model in the decision-making process, which can actually be many different systems. So for instance, if you already have some sort of risk scoring framework inside of your business, which I'm sure you do, this type of architecture is the unifying architecture that allows those systems to interact and allows the integration of the existing decision framework with additional ones, including the graph-based analytics that Chris showed in his demo, and existing business rules, right? For instance, a huge component of what Chris showed is actually quite intuitive. It's quite, maybe I won't say simple, but it's quite logical. For instance, if you have someone who's making many transactions of $4,999.99, rather than doing one larger transaction, that might be indicative that person, that entity, is trying to stay under some threshold, right? Including those business rules alongside of a more sophisticated statistical model and then indeed this graph processing framework is really important, right? That's low-hanging fruit. And this is how you ingest it all. The last piece here is exposing those decisions that this system is making, those recommendations and those flags that were surfaced in the UI, to the investigators and allowing them to make their judgments here at the bottom of the screen. Yep, that's a good recommendation, or no, that's a poor recommendation. And understanding the contextual setting those decisions are made in, feeding that information back into the system to allow it to get smarter and smarter over time. That is human in the loop processing. And that's the sort of the third leg of this stool and the thing that allows this system to really adapt to changing business processes. So let me dive in a little bit deeper to the systems behind the scenes. These are a who's who shopping list of both graph and machine learning algorithms. Again, I'm not going to dive into the details here, but there are lots of pieces of information. There are implementations you can just get from our website if you're interested. But what you see here is that using a combination of graph and machine learning algorithms, we're able to up-level the fraud detection systems that and gain accuracy over traditional types of systems that use standard machine learning techniques, but don't operate on this graph structured data format. So let's just choose one and jump over to the next slide where we're looking at a specific implementation here with respect to round tripping. So Chris showed you a little example earlier with some round tripping information using prepaid commission to be able to clean some money. And what we see in the middle of this diagram is a graph of nodes, those red dots connected by edges, the gray lines. This is just a raw graph where we see financial exchanges going on between entities and using different types of equities to obfuscate. You can see how circuitous these routes are in that screen, to obfuscate the transfer of money, which eventually then goes back to, unsurprisingly in this fully contrived example, the fraudster from the beginning who injected the money in the first place. More generally, and in an orthogonal or really a tangential type of analysis, we can look at risk as a whole. So on the next slide, what we're looking at is on the left-hand side, an unstructured graph. So once you've connected your data in that 5.0 ontology that we mentioned earlier, you can have a look at this big hairball of mess on the left-hand side and see how all the financial transactions in your data structure are related to the various entities, people and companies and equities all alongside each other. And then using the system that Chris showed earlier, you may remember from the demo that he used a clustering algorithm, right? In that case, he mentioned Louvain clustering. But you can use these so-called unsupervised clustering algorithms to wind up with the setting you see on the right-hand side, which is a contextually clustered set of trades that we can then risk automatically by their relationships to each other, as you see there, and we're just coloring them by their predicted risk. Those are surfaced as flags in the UI, and that's what we were looking at earlier in Chris's slides. So let's take a step up, and let me talk about how this works more generally. So all of the graph analytics we do that include machine learning operate similarly to this type of behavior. So we extract information from the graph you see there in step 1, where we have a known entity, whether it's a company or an individual, and we look at all of their known transactions. That's step 2 there. We take that information as input into a traditional, what data scientists call feature vector in number 3, and inject that into a graph machine learning system. And that's what we see down there as injected back into our UI as a flag, like Chris was showing earlier, where we want to highlight risky transactions. Okay, so with all those pieces of information included, let me talk about the 4 pillars of what's happening in AML fraud here. On the next slide, we're showing monitoring, CI/CD in the machine learning space, graph machine learning space. That's how you integrate those things. Active learning, which is the automated updates using human in the loop. And then indeed interpretability, which is the ability to understand why the system is making the decisions it's making. Again, go check out that link if you're interested in the specifics of any of those 4 things. I'll skip over those specifics in lieu of showing you what it looks like in the UI on the next slide. We have those exact metrics I just mentioned for explaining actually showing the explanatory reasoning of the system. So we see some, as Chris showed earlier, we see maybe some community connections leading to that high risk. We show known facets of transactions, which are historically risky. And again, this is just a recommendation we're providing to a human analyst and interpreter to make the decision themselves. And if that person wants to step in deeper to take a look at the details of why the system's making the decisions it's making, they can drill down. And we're showing that here on the next slide, where we have the actual connections inside of the graph as surfaced here in a tabular format, so that those people, the analysts can see historically, have these types of behavior been indicative of fraudulent patterns, and dive into the details of those transactions. Once that analyst has gone through this, they can provide feedback to the system. So on the next slide, we have a couple of panels where we have explanatory reasoning back into the system. Yes, I want to reject this trade, and the recommendation was good, and here's why. That information, as we're showing here, informs the system. It actually retrains the machine learning model behind the scenes and enables that model to effectively gain context, gain expert domain knowledge into the reasons that the recommendations were good or bad inside of that context. So let me show you how this works in delivery, in operationalization here. We've got a a standard template, standard framework here by which you will implement these processes. And they link directly back to those pillars that we mentioned a couple of slides ago. Those, the implementation roadmap, of course, here at every step along the way gives you another piece of the puzzle and actually increases the efficacy of your systems even before the entire implementation is finished. You get integration with graph and machine learning based algorithms. You get online performance. You get automated upgrades in the system. And then, of course, at the end of the day, you get the full recursive adaptive system that we've showed time and time again here during this presentation. So with that, we are going to wrap up here a little bit, and we're going to open the floor up to Q&A. And as we do that, we can just pop over the next slide here if you're interested. A couple more links here for you to dive into to see some specifics. Thanks a lot.
Super. Thanks, guys. I think this was great. Hopefully everybody enjoyed sort of the tour from what we should be doing to what you can do today. And we're super excited. This is out in the field and it's been doing great. Got a couple questions that have come in here. Let's see. The first one here is for Graham. Graham, today we have some Python that we're using to do fraud finding, but we turn them into spreadsheets. How would what you showed here work, or how could we use our work today?
Yep, that's common. As I mentioned earlier, you can integrate that work into the platform. So, of course, your models that are already in operation are probably doing a great job, right? And so what you would do in that case is, instead of routing the outputs just into a spreadsheet, which is kind of cumbersome, I'm sure that's part of the question, we will take those models and integrate their deployment into the platform as it sits today. So you can absolutely use what you have, and we will shrink wrap it into the system.
Okay. The next one is probably for you, Chris. It says today we use part of an Oracle trade fraud system. Could what you showed integrate with what we already have?
Yeah, absolutely. So the set of solutions that I demoed is part of our fraud and financial crimes toolkit. So we build analytic solutions using that toolkit that sit on top of a very varied set of topologies of data source and other integrated systems. The whole point behind some of the solutions that we looked at was pulling that data in a unified view and allowing an analyst or an investigator to be able to see the full picture across all systems. So we absolutely can integrate with systems like the one that you mentioned, Scott.
Okay, fantastic. And it looks like you got one more here. I guess I'll take this one. This one, the question is, how long would it take to plug into my trade blotter and my backend systems to see something like this working? Well, there's a couple of options there. So we do rapid prototypes that are anywhere from 10 to 12 weeks. And realistically, we can use your data that you have, or even synthetic data, to show a proof point like Chris did today. So certainly reach out to us and we can share some more details. All right, I don't see any other questions out there yet, but if anybody's on the call, like we mentioned, the recording will be posted and sent out. We appreciate everybody's time today. And then also, if you have any questions, certainly reach out to us, and we're happy to give a more intimate tour of some of the case studies or the demos. Thanks everybody for the time today.